Question 36. So on this one, we're being asked to basically solve the missing parts of the triangle. So we'll label what we have, and the rest of these questions, as we'll see, we'll use either the law of sines or law of cosines, or maybe a little bit of both in cases. In this case, as long as we have the side and the angle opposite, like a and little a, we'll be able to use law of sines, I think, all the way through. So I'm going to draw this triangle here and label what we have. Something like that. So we got big C, big B, big A, little b, little a, and little c. They tell us little a is 40, little b is 49, angle A is 26 degrees. And that's all we have. And now we need to find the other missing pieces. So we can do that. What we will use primarily, or in this case, is the law of sines. Sine of A over little a, sine of big B over little b, they're all equal. Okay, so that's our law of sines. So we'll start with sine of big A over little a equals sine of big B over little b. Because we have little b, we'll be able to find what this angle is, and then once we have that angle, we can use the fact that a triangle has 180 degrees to find C. Once we find C, we'll be able to find the side opposite using all law of sines. So sine of A is 26 over 40, the side opposite, right? That's got to be equal to whatever the sine of B is, which we don't know, and that this will take an inverse sine to find what that angle is, but we know the side opposite is 49. Okay, so we come along and we can cross multiply. So we get 40 sine of B equals 49 sine of 26 degrees, and then we'll divide by 40, and then you'll see we've got sine of B equals all of this. So if we take the inverse sine of both sides, this cancels, inverse sine of the sine of B, inverse sine of all of this, we will have angle B. So let's see if we can do that with the calculator. Pull this one up. We'll do and we're in degrees, that's important. So we'll do the inverse sine, 49 times sine of 26. You guys were telling me I should highlight that, and we're going to divide, so that's good, over 40. So this should give us angle B, 32.47, and they said to go to at least 4 decimal places, so we'll say that B is equal to 32.4799. We won't round at all. I'm not gonna, because you actually don't want to round. So we go out to here, we'll be fine. So B, but when we do it, they want it to the nearest tenth. So as we're going to record B, record it as 32.5. Okay, but we're going to leave it like this for now as we go and try to find angle. Well, I guess how accurate can you be? So remember, when we're taking inverse sine, though, there's a potential that there could be 2 angles here. And usually when there are acute angles like this, 26 and 32, there's a potential that this could be larger angle, but usually when we've got this side locked in here, we'll be okay. But let's see. Okay, if there were to be a second angle to this, that's what we have to talk about. Okay, so because we took an inverse sine and we've got this angle 32.5. If there were to be a second one that would work, it would be this reference angle over here, which is 32.5. But the way we measure it is from 0 up to that, so that would be 180 minus 32.5. So that means that this side, this angle could be 148. Let me use the calculator on that. So what I'm doing is I'm 180 minus 32.5, potential 147.5. Okay, so yeah, I thought it was close, but so potential having a 147.5. Okay, that's an inverse sine, because again, inverse sine says, okay, we know this value, so we can find the angle, but there's also another place where sine is positive, and that value would be over here. Okay, so we've got that one, but I'm gonna over here put B also potentially could be 147.5. But if you take 147.5, you add 26, there's still just a little bit left. We could make a third angle, so that's a potential. And what that would do is that would sweep this guy, with a smaller angle, it makes C much smaller. So we'll see. Okay, so that's where we come up with the potential for the second angle. And then C will be a different value, and little c will be a different value. And actually, little b will be a different value. We'd have to reevaluate that. Okay. Wait, little b can't be different. Sorry, it was given to us. Sorry, what was I thinking? Okay. We'll see. See if it works out. So then we find this one. So if that's 26 and 32, 26 plus 32.5 is 158, and we'll subtract that from 180. So 121.5. 121.5. So that's another solution. We'll be able to find little c now, and we do that by following through with the law of sines. Let me get some room here. I'm going to kind of get these out of the way. I'll leave that part there. Okay, so we're going to we'll stick with the sine of A, because that was given, and the 40 was given, so that's how we kind of do it. Then we calculate the sine of the 121.5, so we do that, sine 121.5 divided by the unknown. I'm going to cross multiply, so that's a 40 times the sine of 121.5 equals c times the sine of 26. Yeah, because we're solving something different here. And then we divide by the sine of 26. So what we're going to get is, let me write down here, c equals 40 sine of 121.5 divided by the sine of 26. And this is little c. Sometimes it's hard to tell the difference, but okay, so let's go 40 times the sine 121.5, select it all, divided by the sine of 26. So it gets us that C should be 77.8. Now, C is the largest angle, so it should be the largest side. And it's sort of in keeping with the ratios. It makes sense. So that is a valid triangle. We will come back and then take a look at if there's another option. So B was 32.5. Angle C was 121.5. And little c was 77.8. Now, with all of that being done, I'm going to just give myself some room because I'm going to now evaluate and see what in the case if when we did all of this, we took the inverse sine, because remember, inverse sine just tells us that it's finding one value here, but there's another one over here, and there's enough material, enough angle material to actually make that happen. So I'm going to just save myself a little bit. Let's give us some room. And again, we're going to have to do all these calculations, or most of them at least, to just see if they work. We might come up with one that doesn't work, but let's see. Okay, so if B was 147, oh, that's right, I gotta switch back here. Then big C is got to be, I think we calculated it, didn't we? So we got 147.5 plus the 26 for A. Oops. 147.5 plus the 26 for A, that's 173.5. We take 180 minus that to see if there's enough room, and there is. So C would be 6.5. Okay. With that in mind, we can now calculate little c. I'm going to do a back check to make sure that if B was 147.5, that this would still work. Okay, so maybe we'll do that first just to show. Okay, so if this was the angle for B, then we should still have that the sine of 26 degrees over 40, that's big A over little a, should be equal to the sine of 147.5 over 49, and let's see if that still works. It's supposed to. So we cross multiply that, cross multiply that. So we get 40. Oh, we got everything filled in, so yeah. 40 sine of 147.5, does that equal to 49 times the sine of 26? So let's just see if both sides come up. Okay. 40 times the sine 147.5. That's equal to 21.49. That's good enough. And then we'll do the same thing here. We'll take 49 times, 49 times the sine of 26, and we should get the same answer, 21.48, reasonably close within, remember, one is rounded, so we can say, yeah, within a rounding error. That's good enough for me. So this did work, so now we should be able to find C. So again, we go with sine of 26 degrees over 40 is equal to the sine of 6.5 degrees over little c. And we cross multiply. We get c times the sine of 26 degrees equals 40 times the sine of 6.5 degrees. So we divide both sides by the sine of 26 degrees, and that's going to be what little c is. So we just need to calculate this, right? Because divided by that, that cancels with that. So we just got c. Okay. 40 times the sine of 6.5 degrees divided by the sine of 26 degrees, and we get that c is going to be 10.3. We can round for that because it's just nearest tenth for the final answer, right? Okay, so there is this other triangle, and it would work. And that makes sense. So if C is a smaller angle, that would be the smaller side, B would be the largest side, A would be the next. And we did sort of a check on that, so and again, I will check these answers as well, 147.5. But that's how you make sure if there's another triangle. You see, when you do the inverse sine, you check for that other one. And then sometimes it's not, there's not enough, you know, if these other angles are too big, you'd have over 180 degrees, but we didn't. We had 6 degrees left to make it all work. Okay, so that's how you solve